All right, I'm going to talk to you about a couple of stories that I learned about when I was at the American Astronomical Society meeting earlier this month. I was a little bit dismayed. A lot of press releases that I went to that were supposed to be on the web ended up having technical glitches, so they didn't have anything on there. They didn't even describe who was talking or anything like that, so it was kind of a bummer. But one of the intriguing talks was about globular clusters as cradles of life in advanced civilizations. And those of you who haven't seen a globular cluster before, these are really, really compact clusters of stars. They contain anywhere between 100,000 and a million stars. Here's 41 Tucanae. It's, I think, one of the larger ones that has about a million stars in there, and they're in this very spherical shape, and they're really, really close together. Now, where are they in the Milky Way galaxy? Here's a little model of our galaxy. We have the bulge of the galaxy over here. There's the disk. We, as the sun, are out here about 25,000 light years from the center of the galaxy. The whole galaxy is about 100,000 light years across. And the globular clusters are in kind of a spherical halo around the Milky Way galaxy, and they have these kind of elliptical orbits that kind of plunge through around the center of mass. But they move faster in here, and so you tend to find them a little further. Though they do cluster kind of around the center, but they spend most of their time out here. They were well, let me go to just another picture of the globular cluster. These are some of the earliest objects that were formed in the universe. They date back to some of the oldest objects that we can date. Stars in them 13.5 billion years old, the age of the universe. Back then, there wasn't a lot of metals that in other words, heavier elements to potentially make planets. You remember, this article is about looking at advanced civilizations within these globular clusters. Why would they be a cradle for that? Well, we have now discovered a planet in a globular cluster. They're very hard to detect, and it's now thought that planets could indeed form in these clusters. All the more massive, high energetic stars have since died out in these globular clusters, and the lower mass ones here can live, 10 billion, or they've lived the age of the universe so far, but they can live up to 100 billion years here. Now, the advantage of having them all close from a civilization standpoint, if you did develop a civilization on a world, is the stars are really close by to go and get to if you wanted to travel to or communicate to them. So in fact, they are about 100 to 1,000 times closer than what we experience here in our own solar neighborhood. So if we were in one of these globular clusters on one of these stars and looked up, the sky would be bright there. So what these people looked at in their study was there's a couple dynamics that are going on. You can have a planet around a star, and you can have these other close ones by that you can maybe skip onto, but they're also a danger, because if they could be too close, they can strip the planet away. So what they looked at is different stars' lifetime within this particular environment. So one of the things we know about is that there's a sweet spot for where a planet it can be around its parent star to be in the habitable zone, the place where we have liquid water, and that the cooler the stars, the red stars, the ones that are primarily within these globular clusters, that area is closer in to the star. So they're going to be a little bit more protected, even if the stars are indeed actually close together. So they looked at a couple models here, and so these are in log plots, but the basic thing is that this is the lifetime of a habitable zone planet in the globular cluster going up here. And this direction is moving out from the center of the globular cluster on out. And they've modeled this for two different types of masses. One where the mass of the star is only 1/10 of that of the sun, and one that's about 8/10 of that of the sun. So the lifetime of a habitable planet around that size star is indicated by this line. So the smaller planets have higher lifetimes here, and the ones that have I mean smaller stars, I'm saying, and the larger planets, ones closer to the sun, here's their lifetime. So along that axis right there, you see right there, if you come on over here, this yellow line here is basically the age of our solar system. There, 4.5 billion years. So right from here, these stars over here will be able to have, if they developed a civilized life like we did, they'd be able to be stable for quite a few years if you're out there. Anywhere closer, they probably have been stripped before they reached the time of our solar system to get to a civilized planet. So that's one spot there. And then as you get further out here, then things start to, this is showing how far the stars are actually spread out. And when you get further out, the stars are spread out far enough that you're starting to lose that advantage of being in a globular cluster where all the other ones are actually close to you. And I thought this was very interesting because now this is going to direct some of the SETI, the search for extraterrestrial intelligence, to some of these globular clusters. Because in a civilized world like ours, if we could go to another planet, and in fact, in these globular clusters, if they had the same technology as we do, they would know where all the planets were in these globular clusters. They're all close enough with the detection limits that we have to know where these planets are that they could actually go to. They could get to another planet, and you take away that risk of we're always at a risk of destroying our world, right? That once you get to another planet, then you basically take over in this case, the globular cluster. So the search is now going to be on to look for life in here. We're not going to be able to communicate with them, but we might be able to see if there is civilized life in these globular clusters.